Welcome to our channel. Today, we're diving into the icy depths of Uranus, the seventh planet from the Sun. Now, you might be thinking, Uranus, what's so fascinating about a planet that's basically just a big blue ball of gas? Well, my friends, prepare to have your cosmic perspective shifted. Uranus is a world of wonder, full of surprises and mysteries that continue to baffle even the most seasoned astronomers. Over the next few minutes, we'll uncover 10 fascinating facts about this enigmatic ice giant, from its unusual tilt and frigid temperatures to its faint rings and numerous moons. So buckle up, space cadets, and get ready for a journey to the outer reaches of our solar system. Uranus is classified as an ice giant, but not because it's covered in skating rinks. No, it's the stuff beneath the clouds that counts. Unlike Jupiter and Saturn, which are mostly hydrogen and helium, Uranus is full of heavier elements. We're talking water, methane, ammonia, all in supercondensed icy forms. Think of it like a giant slushy, but instead of cherry flavor, it's, well, cosmic. This ice isn't something you could skate on, though. The pressures and temperatures on Uranus are so extreme that these materials behave in ways we're still trying to understand. It's not just solid, it's not just liquid, it's a whole other state of matter. And that, my friends, is what makes ice giants so fascinating. This unique composition tells us a lot about how Uranus formed, different from its gas giant siblings. It suggests that Uranus formed further out in the solar system, where it was colder and icier materials were more abundant. Then, over billions of years, it migrated to its current position. Now, let's talk about Uranus's most famous feature, its tilt. This planet is practically doing a cosmic cartwheel. While other planets spin on their axis like upright tops, Uranus is tilted on its side with an axial tilt of 98 degrees. Imagine a world where the sun is practically glued to the horizon for decades at a time. How did this happen? One theory is that early in its life, Uranus got into a cosmic brawl with another planet-sized object. This collision, billions of years ago, could have knocked Uranus on its side. Talk about a bad day. This extreme tilt results in the most extreme seasons in the solar system. For about a quarter of its orbit, one pole is pointed directly at the sun, while the other is shrouded in darkness. Can you imagine living on a planet where a season lasts for 42 Earth years? When we look at Uranus through a telescope, it appears as a serene blue-green orb. But don't let that tranquil hue fool you. There's some serious chemistry going on up there. The reason Uranus looks the way it does is because of methane, the same stuff that gives some swamps their distinctive aroma. You see, methane is excellent at absorbing red light from the sun. So when sunlight hits Uranus's atmosphere, the methane gobbles up all those warm colors, leaving behind the cool blues and greens that we see. It's like a cosmic color filter, turning Uranus into a giant celestial disco ball. But there's more to this story than meets the eye. The exact shades of blue and green, and even the presence of subtle cloud bands, can change over time. This tells us that Uranus's atmosphere is dynamic and constantly evolving. Chapter 4, the coldest planet. Now let's talk about temperature. You might think that Neptune, being farther from the Sun, would be the coldest planet, but that title actually belongs to Uranus. At its coldest, Uranus's atmosphere can plunge to a bone-chilling minus 224 degrees Celsius or minus 371 degrees Fahrenheit. That's colder than a witch's. Well, you get the idea. Scientists are still trying to figure out why Uranus is so darn cold. One theory is that its extreme tilt plays a role, somehow disrupting the flow of heat from its core to its upper atmosphere. Another possibility is that the ancient collision that knocked Uranus on its side also stripped away some of its internal heat. Whatever the reason, Uranus is a stark reminder that space is an incredibly cold and unforgiving place. Chapter 5, the elusive rings. When we think of rings, Saturn immediately springs to mind. But did you know that Uranus has rings too? That's right. This icy giant boasts a system of 13 known rings, but they're not as flashy as Saturn's. In fact, they're downright faint and difficult to see. Unlike Saturn's rings, which are composed mostly of bright icy particles, Uranus's rings are made up of dark rocky material. Imagine chunks of coal orbiting the planet, and you'll have a pretty good idea of what they look like. Scientists believe that these rings are relatively young, cosmically speaking, and may have formed from the breakup of a moon or moons that got a little too close to Uranus's gravitational pull. Chapter 6. A Shakespearean Court of Moons. Uranus isn't alone out there in the vastness of space. This icy giant is accompanied by a retinue of 27 known moons, each with its own unique story to tell. Now, most moons in our solar system are named after figures from Greek mythology, but Uranus does things a little differently. Instead of Zeus and Hera, Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope. We've got Titania and Oberon, the fairy queen and king from A Midsummer Night's Dream, as well as Miranda, Ariel and Umbriel, all characters from Shakespeare's The Tempest. These moons come in all shapes and sizes, from tiny potato-shaped objects to larger worlds with complex surfaces shaped by volcanoes, canyons and ancient impacts. Chapter 7. A Telescopic Discovery. For centuries, humans gazed up at the night sky, unaware that there were planets beyond Saturn. That all changed in 1781, when a musician and amateur astronomer named William Herschel made a remarkable discovery. While scanning the skies with his telescope, Herschel stumbled upon a faint greenish-blue object that he initially mistook for a star or a comet. However, as he continued to observe this object over the following weeks and months, Herschel noticed that it was moving against the background stars, and its orbit was unlike that of any known comet. He eventually realized that he had stumbled upon a new planet, the first to be discovered using a telescope. This discovery revolutionized our understanding of the solar system, expanding its known boundaries and paving the way for the discovery of Neptune and Pluto in the centuries that followed. Chapter 8. A Lifetime Journey. If you thought Earth years were long, wait till you hear about a Uranian year. It takes Uranus a whopping 84 Earth years to complete one orbit around the Sun. That means that if you were born on Uranus, you'd only get to celebrate one birthday every 84 Earth years. This incredibly long orbital period is due to Uranus's vast distance from the Sun. In fact, Uranus is about 19 times farther from the Sun than Earth is. To put that into perspective, if the Sun were the size of a basketball, Earth would be a tiny peppercorn about 25 meters away, while Uranus would be a marble almost half a kilometer away. Chapter 9. A Day in the Fast Lane. While Uranus takes its sweet time orbiting the Sun, it's a real speed demon when it comes to spinning on its axis. A day on Uranus from sunrise to sunrise lasts only about 17 hours and 14 minutes. That's even shorter than a day on Earth. This rapid rotation, combined with its extreme tilt, creates some truly bizarre weather patterns on Uranus. Imagine winds whipping around the planet at hundreds of kilometers per hour, while the Sun hangs motionless in the sky for decades at a time. It's enough to make your head spin. Chapter 10. The Mystery of the Missing Heat. We've seen that Uranus is a planet full of surprises, but perhaps the biggest mystery of all is why it's so darn cold inside. You see, unlike other giant planets like Jupiter and Saturn, which radiate more heat than they receive from the Sun, Uranus emits very little internal heat. Scientists are baffled by this lack of internal heat. One theory is that the ancient collision that knocked Uranus on its side also disrupted its internal structure, preventing heat from escaping from its core. Another possibility is that Uranus has some sort of internal insulation that traps heat deep within its interior. Whatever the reason, this lack of internal heat has profound implications for Uranus's evolution and atmosphere, making it a unique and intriguing object for further study. Outro. Until next time, space explorers, thanks for watching. If you enjoyed learning about Uranus, don't forget to like, subscribe, and hit the bell icon for more fascinating space facts. We've only just scratched the surface of this icy giant, and there's still so much more to discover. Who knows what other secrets Uranus holds, hidden beneath its blue-green veil. Until next time, keep exploring the cosmos and never stop asking questions about the universe around us. See you next time.